Hi everyone, welcome back. We're going to do another Leetcode today, and in this video we're going to do the majority element problem. So in this problem we are given an array of array nums of size n, and we need to return the majority element. So the majority element is the element that appears more than n divided by 2 times. So you may assume that the majority element always exists in the array. So basically you have an array and then the majority is 3, so your output has to be 3. So pretty straightforward problem. So let's just try and do the simplest approach we can do. So we can just iterate through this number array, and then while we're in each iteration we can just count the number of elements that exist in the array of that given number. So let's just code that up and we can see how it looks like. So first we have to loop through the number array. So I0, I less than nums dot length, then I. So let's increment. And then what we can do is we can create a variable inside the loop and say let's count to 0. And then we're going to loop through again and say, okay, g less than nums dot length, and this time j plus plus. And then in this inner loop, we're just simply going to check if nums I is equals to nums j, then we can just increase the count by 1. And then once we're done with this inner loop, we can just check if it's the majority element. So we know that the majority equals, I'm just going to put a math.floor so we don't have decimal places. So we're just going to say nums.length divided by 2. So that's the majority. So any count that matches that or is greater than or equal majority, then we can just return nums I. So that is the simplest solution, and we're just gonna quickly run this test case and see if it actually works. So yeah, we have a pass test case. Let's submit it. The 6.5. See where should I just do a +1? Okay, let's just run that. Okay, I think we can just do a ceiling instead of a floor. See if we can pass that test. Okay, so don't floor it. Look at the ceiling, you round it up instead of running it down. So this is the simplest solution for this problem. So basically we have a loop through the whole number array, and inside that each iteration we loop through the loop again and just count the number of times it actually appears. So in this case the runtime actually is not good. It's a double loop, so we have a runtime of n square. And we have a space complexity of we have a constant space complexity because we're not saving anything, so it doesn't use that much memory space. It just basically takes the number length and divide it by 2. So this is the simplest approach, but it's a bit slow. We can improve the runtime, and what we can do is basically we can create a object and or hash map. We can call it frequency, and what we can do is when we're iterating through this nums array, we can just say frequency nums I equals, we're going to check if it exists. And if it doesn't exist, we can just initialize it as 0. And then we can just add 1. So that is the frequency. And what we can do is, if this is greater than majority, then we can just return that number. So let's just run this and see if it works. And it works. Let's submit it. And as you can see, the runtime improves a bit. So this time the runtime is a linear, so O of n, but it takes up memory. So every time it's gonna take O of n space complexity. So the first approach basically is slower, but it doesn't take much memory. But the second one takes a bit more memory, but the runtime is faster. So there's another solution that I want to show you. Is basically what we can do is we can actually sort this out. So basically we have this 3 2 3, we can say 2 3 3 and just iterate through once, or we can just look at the nums n2 position and just look at that and see if it is the value. So basically let's just do that. Okay, so what we can do is we can just say return nums dot sort. So we're sorting it out, and then we can look it at the majority index, and then if that should return the value that we're looking for. So we don't need this frequency. So let's try that. And it's a set test case. Undefined. Okay, let's just floor this then. See if it works again. Okay. Okay, so this is accepted, and as you can see, it's a bit it's actually a bit faster. What it does do is it uses this sort algorithm, and most sorting algorithms in programming languages, they have a runtime complexity of O of n log n. So basically that is not as fast as O of n when dealing with smaller arrays, so smaller array size, but as it gets larger, it gets faster. So this can be argued that is actually a lot faster than your linear time complexity. So you can use this as a third option to have a better approach or better runtime. And this space complexity will probably be depending on how this actually works in JavaScript. I'm not sure about that, but some programming languages, they just sort the array in place so it doesn't take extra memory, but sometimes it actually makes a copy in memory and sort it out. So that one also takes n log n, or it takes I guess it takes O of n space, because you're recreating the whole array. You're making a copy of array, a second copy of the array. So we've come to the end of this video. I hope you enjoyed it, and if you did, hit the like button and subscribe to the channel, and also press the bell for any notifications. If you have any questions about this problem, just drop a comment down below, and we're going to do more of these Leetcodes in the future, so stay tuned for that, and I will see you in the next video.